So now that we've done some trig proofs, we have to figure out where in the world does the double angle formula come in handy. So naturally we chose the easiest application, a rocket to Russia. So here we have Alex, Luke, and Caden, or Team Elk, which is us, and we're going to figure out at what angle we need to make it to Russia while going to a speed of 75,000 meters, or 7,500 meters per second, and the width, and with gravity obviously being 9.8 meters per second squared. And then the distance between Toronto, Ontario, and Moscow, Russia is 7,840,000 meters away. So for this, we're just going to use a handy formula. It is the distance, which is this, equals 4 times the velocity squared over gravity times sine theta cos theta. But we can't solve for that angle with both of those thetas here. So to start, we're going to do a nice tricky move, okay? So we're going to go, we have our distance equals, and then we're going to split that 4 into 2 parts. So we're going to do 2 times velocity squared over gravity, and then multiplied by 2 sine theta cos theta. Looking familiar? It should. That 2 sine theta cos theta is actually just equal to 2 sine 2 theta, which we found out doing our double angle formula. So we can simplify that even more by saying distance equals 2 times the velocity squared divided by gravity times sine 2 theta. Now, this still isn't very much help for us because we don't have any numbers in it at all. So we're going to do a few calculations. So first, we'll take our velocity and square it. So we do 75,000 squared, and then multiplied by 2, and divided by gravity. That will leave you with a massive number, okay? But we're going to start, so we're going to have distance equals a really big number that I'm not even going to try to pronounce. And then times sine 2 theta. So now what we're going to have to do is we're going to have to get sine 2 theta on its own. So we'll do our 7,840,000 divided by our extremely massive number. And all of that will just equal sine 2 theta. So when we do that, we'll be left with 0.683. Now, this is a lot simpler. As you guys should already know, we can just simply solve for theta. So what we'll do is we'll do inverse sine of that 0.683